Yes, you are.
Yeah. So, very good morning to all. Just a second. Uh, am I visible?
Yes.
Yes, yes.
Yeah. So, we are very privileged to have Dr. Shankar Venugopal today here with us for our second episode of Gyaniki Tech Talk. So, he is a very renowned personality in the automotive domain. So, I don't think so. We need any formal introduction, but still, I would like to highlight a few key points. Like he's currently a vice president of Mahindra and Mahindra, and to prominently highlight that he is recognized as one of the top 50 innovative leaders by World Innovation Congress 2020. He is also a co-inventor of 10 issued US patents and 10 Indian patent applications, and he's a really a renowned technology leader in the automotive domain. So, Dr. Shankar, we are really very honored to have you today for our second episode of Gyaniki Tech Talk. And before we move ahead in the session, I would request if you can share a few words or thoughts about like today's session or like something with us.
Sure. Thanks, Rutuja. Very happy to be with you all here today on this Saturday morning. Saturday seems to have some kind of a special charm because Friday we are so busy doing the what is important for today. And Sunday, we actually want to take off and get some rest. But Saturday is an ideal day when we can actually do something which is important for the future. Um, and from that perspective, it's very apt that we chose to look at the future of the mobility industry and also talk about what are those skills that will be very important for us, for those of us who are aspiring to build our career in the automotive industry. What are those skills that we need to pick up so that we'll be able to play a very important role in shaping the future of mobility? That's the scope of the discussion, and I'm glad that we are doing it today because this is the right moment because we see a lot of discussions around us. This is the right moment for us to start thinking about it and start preparing. So I'm very, very happy to be with you all here today and talking about this very important topic.
Uh, Thank you so much, Dr. Shankar. So, like for your valuable insight about the session today. So, Harsh, I think we can start with the Q&A.
Harsh, we cannot hear you.
Yes. Sorry. Dr. Shankar, you've been in the industry quite a while in order to see how it's transformed, especially in the Indian context, right? From it not being too developed to the point where now it is getting on par in a lot of areas, and especially where it comes to like the e-mobility or the mobility sector in general. How do you envision the future, right? Current circumstances and wherever we have come to so far. What do you envision the future to be from a general standpoint as well as from a minor standpoint?
Sure, sure. Glad that you asked this question because this could set the context for a lot of the things that we will be discussing today. Um, if you look at the future of the mobility industry itself, it's shaped by a few technology disruptions, which would encompass electric vehicle technology, the connected vehicle technology, also the autonomous vehicle technology. These three technology disruptions are fairly big by themselves, and we are looking at the convergence of these three to create a sustainable mobility technology for the future. And added to these three technology disruptions is also a business model disruption of shared mobility. So when you look at these four coming together, I see a complete paradigm shift in terms of how the mobility of the future would be. And this is a time when all those preparations for making each of these individually and also the convergence happen. So this is very important because it needs sufficient planning, because these technologies bring their own set of challenges. Many of them are cross-domain and cross-functional in nature. So it needs a very clear vision and a lot of skilling and preparation to make sure that we do it the right way. And we, as a country, we have the potential to leapfrog various other mobility technologies and be the first to create this sustainable mobility technology for the future. So that's the reason why we can't afford to do any mistake. We need to do this right. There's a golden opportunity in that sense. And it'll be great if we can all bring our knowledge and resources together and understand the various dimensions of this mobility framework and systematically start innovating towards all these dimensions so that we are able to build a holistic ecosystem around electric mobility. That's a kind of vision I have in terms of how this mobility space is really evolving. And it's evolving pretty fast. It's gone are those days when this evolution was slow and incremental in nature. Today we are talking about exponential rate at which these technologies are evolving and converging, so that these changes, which typically used to happen over 10 years and 20 years in the past, can happen in 1 or 2 years. So that's a pace at which things are evolving towards the future technology.
Of course. Talking about it not taking 10 years anymore, we know that especially in the advanced space, not just the electric vehicle space, but even the connected car tech or shared mobility. What sort of timelines do you see, or do you foresee, again from an Indian context, to for these to convert into ground realities, right? For example, let's say that there is a lot of discussion and talk about autonomous vehicles or vehicles that are smart, but that, as you know, can become a big challenge for, say, the Indian context. So, as an example, so how do you see that?
Um, if you look at connected vehicles and electric vehicles, they are here and now. So today you can get a vehicle which is an electric vehicle, a fully battery powered electric vehicle, and which has good smart connected features. So that is very much here right there. But when you look at autonomous features, yes, definitely it will take some time for it to evolve. Um, at least in the Indian scenario, it's going to take some time. But that is only when you are looking at it from a passenger car perspective. For example, we have an ongoing program on autonomous tractors, where we have already built a few semi-autonomous tractors, and they are on the field, and we are doing a lot of testing of these vehicles. And these are semi-autonomous in nature right now. And these applications for autonomous vehicles in terms of farm applications or even construction, mining, border patrolling, those kind of applications can be done even today. It's not difficult at all. The sense the technology is ready and the application space is also quite ready to try out a lot of these things. So there is no need to wait for things to happen. But autonomous vehicle on the Indian roads may take some time. That's true. And that will also go through different levels of autonomy. And eventually we will reach there. But what I'm looking at is a convergence of all three in a very, very systematic manner. So to start with, it could be a battery powered electric vehicle with limited connected features and maybe no autonomous features at all. Then slowly it will evolve to a state where you may have parking assist and some drive assist features coming in and more connected features coming in. The long run, the electric vehicle itself may evolve into a state where we are talking about a battery powered electric vehicle, but if you are connecting the battery to the grid, which is again powered by fossil fuels, then we are not totally green. So in the far if you look at far, when I say it's a 10 to 20 years time frame, not beyond that, if you are looking at renewable sources for generating electricity like solar, wind, and such a clean electricity being used for charging the electric car also, so that you can look at it as a totally green option. So that's how the electric car may eventually evolve, so that it becomes easy to charge the car. Parallelly, the infrastructure would also evolve so that you will have fast charging stations everywhere. And when this evolves, what you will eventually have is a vehicle which is electric, which is run on a clean source of electricity, and which has sufficient connected features and autonomous in nature, and it will be a shared vehicle also, so that you need not necessarily own it. If you own it, well and good. But if you don't want to own it, you'll also be able to lease it or hire it whenever you need. So this is how I see convergence of these multiple technologies happening as we go along. And the time frame that I'm looking at is about 10 to 20 years from now. And a lot of what I said can happen in the 5 to 10 years time frame itself. And more of the autonomous aspects may happen a little longer time frame they may take. That's why I'm considering a 10 to 20 years. Otherwise, with the pace at which technology is evolving, a lot of these developments would happen in a 5 to 10 year time frame.
Yes, I agree that that when it comes to autonomy, it's not just passenger vehicle applications, especially areas such as like you mentioned agriculture. They can
Yes,
be extremely valuable, and maybe and even more maybe one of the areas where the development starts with agriculture and gets into passenger vehicles.
sure, sure.
So my next question is something that I'm sure that you heard a lot about or have been probably asked before, and it's sort of an ongoing right now the word when it comes to the whole point of Atmanirbharta, right? What do you see? How do you see that? Like what from again an Indian industry context? Are we really? I mean, we definitely are not at that point yet. But what do you see? What do you see it take to get there? Like, what do you see as the major gaps there?
Sure, sure. So if you're looking at self-sufficiency um, in this space, which is electric, autonomous, and connected, um, electric definitely. The good thing about an electric vehicle is it will have fewer components as compared to today's internal combustion engine based vehicle. Uh, but some of these components will be carried over from the current technology. Some will be totally new, and a few will be dropped. In the sense, what you see in your vehicle today may not be there. So when you talk about building the ecosystem, it's a combination of all these three. What you can take forward, what you need to drop, and what you need to create new. So let's start with the new part, which is typically the lithium-ion batteries and also the electric motors and all the electronics that comes along with a vehicle like this. And also there is a need for lightweighting the vehicle itself. So these are some of the things that would come in as new. Few things that would continue in a sense, not a big disruption, but there will be evolution, but it will still continue. Would be the seats, suspensions, tires, those kind of technologies. Even the electric car would need all this. So it's going to have a continuous evolution rather than any disruption in that sense. Of course, a lot of the moving components and the components related to the engines and powertrain will undergo a fundamental transformation, and so you won't see many of them in this new vehicle. And so those are the ones that we need to look at the suppliers who are traditionally been supplying these components, how they can reinvent themselves and get into the newer technologies. So primary focus would definitely be on the batteries itself and lithium-ion batteries, uh, right from cell manufacturing to overall assembling a lithium-ion battery pack, and then of course the electric motors. From a self-sufficiency perspective, one of the bottlenecks could be the materials that goes into the construction of these two important subsystems. For example, if you look at the lithium-ion battery, we are looking at materials like lithium, cobalt, which are key materials for the electrodes of these batteries. And these materials are not uniformly distributed across the globe. They are concentrated in certain geographic regions. So one of the early technology problems that we need to address is how to mitigate the risks around the availability of these critical materials like lithium and cobalt. And when you look at the motors, again, we need very strong magnets if you are looking at making compact motors. And this is where the rare earth materials would come in. And just like lithium and cobalt, the rare earths are also concentrated in a few regions in the world. So we need to look at either alternative technologies or ways in which we can mitigate the risk around the availability of the rare earth materials also. So from an Atmanirbhar or a self-sufficiency perspective, I would say that we need to identify some of the materials bottlenecks and start developing alternative technologies or approaches to systematically mitigate the risk around availability of critical materials. Otherwise, I'm quite confident that we'll be able to develop either the battery technology or the electric motor technology, or all the associated electronics, everything in-house. I think we have a fairly good knowledge base and a network of experts across who can do it indigenously. So I'm quite confident about it.
So yeah, that puts things into perspective. Yes, that usually the biggest bottleneck tends to be not being
Yes,
dependent for resources
yes,
and being able to develop something that suits the local conditions.
that is true.
And my I think my next question is sort of builds on that. So multidisciplinary, right, is sort of a buzzword these days. Even Mr. Anand Mahindra has mentioned it a couple of times. And where this comes from is the fact that this, especially in our context, the transition to e-mobility at a development level has been quite sudden. So how what are your thoughts on this whole idea of, or of skill on being multidisciplinary? What is
Sure. See, even um, getting into electric vehicles, there has been a need for us to take a multidisciplinary approach when we educate our engineers. Because it's only in an academic setup you see separate departments like electrical, chemical, mechanical, electronics, and so on. Once we come to the industry, any product actually cuts across all these engineering domains, and all our product design engineers get to work in cross-functional teams where you would have a mechanical engineer, an electronic engineer, electrical engineer, a computer science engineer, all of them working together to build a product. So for the industry, you don't have this partitions of all the departments that you see in a university. The moment you enter the industry, all these walls go away. And this has become all the more necessary when we talk about the next gen technologies of electric, autonomous, and connected. Traditionally, the automobile engineers have all had a mechanical engineering background, and primarily because most of the parts of the current generation vehicles are mechanical in nature. But going forward, you will see the electric vehicle, autonomous and connected, bringing together at least four domains of engineering together: mechanical, electrical, electronics, and also computer science. So at least one need to have at least working knowledge of these four engineering domains if when you enter the mobility industry. So there is a excellent white paper that was written by Physita, part of the SAE organization, which had come up with this recommendation that a mobility engineer of 2030 should have four skills, which is mechanical, electrical, electronics, and computer science, in order for them to work on the next gen products and make an impact. So just give me a moment. I'll just connect my laptop to the PowerPoint. Just give me a second. Okay. That's it. So we are looking at basically training our engineers at the interface of four engineering domains: mechanical, electrical, electronics, and computers. And this is what the mobility industry would need. And this need is, I can already see the need for this, and this is going to steadily grow. So that by 2030, we are looking at every mobility engineer having knowledge of all these four domains. That's how the skilling part of it is really evolving.
Okay.
And added to this, so far we talked about only the engineering knowledge. That's a foundation. Added to this are skills like creativity, innovation, problem solving, design thinking. These are again ways in which the mobility engineer will be able to use his domain knowledge, solve the important problems, come up with innovative ideas, and make an impact. So these are the next set of skills. First layer, we talked about four engineering domains: mechanical, electrical, electronics, and computer science. The next layer, we are talking about skills that would involve creativity, innovation, problem solving, and design thinking. And on the top layer, we would need yet another set of skills, which would be more in terms of communication skills, ability to collaborate and work in cross functional teams, and ethics and values, ability, some of the leadership skills, which would help every mobility engineer to be a leader in their own space. And then they'll be able to not just solve today's problem, they will also be able to visualize what would be the important problems of the future, and they'll be able to systematically work on those future oriented problems. So we are talking about a foundation of four engineering domains, then a layer which would involve innovation and design thinking, then the top layer which would involve ability to communicate, collaborate, and also have a future focus. I think these are the kind of skills that we are looking at for mobility engineers. And this is the right time for us to start thinking and make the necessary changes in our education approach so that we'll be able to churn out a lot of young engineering graduates with all these skills.
Absolutely. So you've been involved or a big word when it comes to this skill development area, right? It's at Mahindra Technical Academy, things going on at Research Valley. So how is Mahindra the company or looking at this area? Like how is what sort of are there any sort of projects or programs that are in place to be able to have, like you just said, right, that engineers can no longer be just have a single set of skills. They would need to be having, a various set of skills depending on which part of the industry they're working in. So
Sure.
how do you see, like what sort of programs are, can you shed some light there?
Yeah. So apart from driving the technology innovation as a vice president for both the automotive and farm sectors, technology innovation and new products, I'm also the dean for the Mahindra Technical Academy. So what this role brings in is I need to basically keep an eye and make sure that all our engineers are able to pick up the engineering competencies in future technology areas. So my work starts from the fresh engineers whom we bring to the Mahindra Research Valley and goes all the way to a chief engineer who has spent maybe 20, 25 years in that particular organization or in the particular domain. So I need to look at the needs, the learning needs of people across this broad spectrum. So when we look at least the fresh BTechs and MTechs whom we hire from the engineering institutions across the country and bring to the Mahindra Research Valley, I basically first strengthening the engineering fundamentals and having this cross-domain knowledge. So if there is a mechanical engineer joining the Mahindra Research Valley, I would basically start with giving him exposure to the domains of electrical, electronics, and basic coding and programming. This is one thing we start with. Same way, if you have hired an electronics engineer, we would give him knowledge of mechanical engineering, electrical, and computer science. So this kind of a cross-domain engineering exposure is what I typically start with. And it's not just online learning or classroom lectures, but we create small projects in which they can work in a cross-functional team and build something. And that's the fastest way to pick up these skills. And the next layer, I also train them in a systematic innovation method called TRIS, which is a theory of inventive problem solving, which trains these engineers to solve problems in a very, very systematic and structured manner and come up with innovative ideas. And along with this, we also train them on how to come up with patentable ideas so that all their innovative ideas can sufficiently be patent protected. So this is a knowledge which every engineer should know in terms of innovative problem solving and also patenting their ideas. So this is something we do. And the third important skill which I make sure that they all pick up is on design thinking. Here the focus is to make the engineer interact with the customers, understand the needs of the customer, and then translate that insight into specific product features that we should build into our product. So we are looking at one is TRIS-based systematic innovation. Then we are looking at IP creation, and then we also look at design thinking. So this is at the second layer. The third layer also look at certain new technologies, one of which is data science, which will include the introduction to artificial intelligence and machine learning. This is again something we make sure that all our engineers are trained in basic data analytics because there is so much of data that's available in each of these domains. And if these engineers are able to analyze this data and extract insights, that will greatly accelerate their work and also would provide a strong data support to a lot of their recommendations, and that will make their life easier, especially when you're a young engineer just starting your career. It's good to have your recommendations supported by strong data and analysis. So we make sure that all our engineers are trained in data analytics. So we talked about cross-engineering domain exposure, then we talked about innovation, design thinking, and also IP creation. Then finally, data analytics. These are fundamentals, a minimum must have for an engineer who is just starting his career in the mobile.
Right.
Yeah.
Since we're on the subject, and only if you are able to share, can you tell us of any exciting projects that are already in happening or have recently happened through these programs or have been undertaken through these programs?
Sure. So we have programs both in the automotive and the farm domain. For example, farm, I did mention that we have projects on semi-autonomous driverless tractor program. That's something very exciting. And along with this driverless tractor programs, we are also looking at smart agricultural implements, how we can make traditional agricultural implements smart by using sensors and a layer of IoT on this, so that all this can eventually come together and lead to a precision farming based approach, which should help the farmers to leverage technology and double or triple their productivity. This is very important for us. And so we start with exposing our engineers to the agricultural practices, understand the needs of a farmer, and then start democratizing technology in such a way that advanced technologies are made available to farmers at a very, very affordable cost. So they'll be able to use technology to get a lot of their problems solved. This is a very interesting and a very exciting space. And there is so much of opportunity for innovation in this space. And the other space is automotive related, where we look at electric vehicles and also lightweighting of the vehicles, also systematically experimenting with the different levels of autonomous features. And then we start with very small, compact vehicles, which the engineers can play around with and get confidence. And then slowly we scale it up to a level where we can even test these vehicles within our campus. And then we go for real applications based on strengthening this fundamental knowledge. So we don't directly jump into something very advanced. We do it in a step-by-step manner so that the engineers are very, very comfortable with all the engineering fundamentals in all these new technologies. But a lot of it is hands-on. We make them do things so that they are not just getting conceptual knowledge, but they get the confidence to solve real world problems and able to work at the interface of multiple technologies and bring all this together to build a product that can deliver the needs of the customer. So a lot of it is hands-on and experiential based education that we are looking at. And in this current time where people are working from home and also learning from home, a lot of it we have made it in a blended learning form where the initial foundations will be through online learning. Then there will be virtual classroom interaction with the experts. And then there will be projects, mini projects in which they will work on applying this knowledge. So these 6 months, we are able to dedicate a lot of time for training our engineers and building these future skills. And this has been a good time for reskilling that way.
Fantastic. Yes, yes, I agree, and I can from personal experience say that I guess everybody will agree that being able to actually work on something with your hands is gives you a completely different perspective compared to just learning about it in text. So both are equally important.
Sure.
And I guess to round it off, right, we have talked about where the industry is headed, what sort of skill development we are looking at, and what is the available resources. Now, I think an equally important area tends to be identifying talent, right? We especially in our context, there's a certain way that from an HR process, right? How talent is selected, how talent is identified. That tends to be a pretty, I would, at least in my opinion, say that an old school way of doing things, especially in the automotive sector or engineering sector per se. How do you see that, like this whole idea of the talent is like to find the talent is really where it starts. How can that change or improve to be able to make it better for people who actually deserve to have an opportunity sort of thing?
Sure. Yeah. If you look at what we should look for in candidates when we are trying to hire them, um, I would look for three things which are very, very important for them to be successful in their career. The first would be curiosity. Okay. How curious they are in terms of observing things around and trying to go a little deeper, connect things, and understand why, stuff like that. The second would be their ability to collaborate. This is important because each one comes with certain domain knowledge and certain unique skills, and their impact would be manifold if they are able to collaborate with others with complementary skills. Otherwise, on their own, they'll be having only a minimal impact. So their ability to collaborate actually amplifies their impact. The third is their learnability, the willingness to learn, willingness to go out of their comfort zone and learn new things. So we are looking at assessing a candidate on three things: curiosity, collaboration, and learnability. So if this is what we have to look for, then a typical half an hour interview, a half an hour time may not be sufficient to study all these things and compare two candidates A and B and say whether A is better than B in terms of curiosity, collaboration, and learnability. So it needs definitely a longer interaction to do that. And also, it cannot be across the table interview asking them a few questions and they answering. That may not reveal all these attributes, the characteristics. So, if you look at the way the interviews should evolve, one is it should be a longer time of interaction, which can happen. Suppose if you are offering the students a summer internship and they have come to you and spent 2 or 3 summers with you, and so that you have had sufficient time to observe them and conclude where they are in terms of curiosity, collaboration, and learnability. Then there are lesser chances that you'll be making a mistake when you compare two candidates A and B. Second is, since a lot of it, I can't ask, are you curious? There is no answer, yes or no to it. I have to observe. I have to observe him under different scenarios and see how curious he is, how good he is in collaboration, and how smart he is in terms of learning new things. So here again, we have to have some kind of a lab where we can let them go and do things where we can observe and then conclude how they are in these three dimensions. So we have to move away from a simple question and answer kind of an interview and get into mood of creating a conducive space, a lab kind of a thing, maybe a curiosity lab, a collaboration lab, a learnability lab, and then let them there maybe for an half an hour or so, or maybe even a longer time, and observe how they behave, how curious they are, how comfortable they are in collaborating with others. Typically, you remember in those MBA admissions, we used to have a roundtable discussion and stuff like that. Even that, people struggle because some people, by the time they make up their mind and start to speak, the time would have been over. And so, even though they had a good idea, they would have never had the chance to speak. And everybody would be trying to speak. So, time constraint should go away so that we get a longer time to observe these people. And also, the right ambience, the right environment, like a curiosity lab, a collaboration lab, a learnability lab, where we can observe how these people work and then decide how good they are in these three skills. But this is a matter of time where we figure out how to do it. But what to look for, I'm very clear that what to differentiate a mobility engineer who is going to be successful in the future would be curiosity, collaboration, and learnability. This is something very important. So we have to figure out ways in which we can assess candidates for these three skills.
Absolutely. Sir, we have sort of walked through, what the policy or what the overall tech and how the skills are coming up. Now we are sort of going to switch to a few questions from the audience, which is getting a little more specific on technology.
Sure, I'll just take half a minute to kind of summarize what we talked so far before we get into the Q&A. So
Absolutely.
the first area we talked about is reskilling. So where we need to pick up newer engineering knowledge, problem solving skills, and also leadership skills. So that is the first phase. Then we also talked about rebuilding the ecosystem, which is from an Atmanirbhar self-sufficiency perspective. We need to build the whole suppliers ecosystem around electric mobility. So that is the rebuild part. Then in this context, we also talked about certain critical materials and the need for mitigating the risk through research on alternative technologies. But there is a short-term solution before we get into that. That is our ability to reuse. So how can we design these components in such a way that we can easily reuse these critical materials? So there is a lot of technology innovation opportunities around reuse of materials in this space. So we are primarily looking at reskilling, rebuilding, and also reusing. That could be a quick summary of what we have discussed so far.
Okay, thank you, sir. Thank you for that. So this is one of the questions from the participants. What is Mahindra's so especially from a passenger car application perspective, or on road use is what I was like. I think would be better to use. What is Mahindra's roadmap from? So we all know that currently, even though we are very much working towards an electric taken by OEMs tend to differ, right? Everybody has a certain way and roadmap for how they want to transition from ICE to electric vehicles. How is Mahindra going about it, and what is the thought process there, or what's the roadmap there?
Sure, sure. So we started our electric journey quite early, actually. We are the earliest to build an electric vehicle. It was the first vehicle was called Bijli, and this was some kind of a electric um, six-seater kind of a vehicle, which we built very early on. But those days, a lot of the components had to be imported, and it was quite expensive. So many customers could not afford this electric vehicle at the time. Then few years after that, we could acquire Reva and Mahindra Electric was born. And then systematically over the years after that, we could expand the portfolio of our electric vehicles. So remember E2O, which was a two-seater, which was initially a two-seater, which became a four-seater, and then the E Verito, and a variety of electric vehicles, which helped us to systematically expand the portfolio to the extent that we even got a electric auto, the Trio, and so that is happening in one direction. And what can happen in the long run is today we are looking at our current vehicles and converting them to electric. In the future, we may also look at going for an entirely from scratch design of an electric vehicle. So that is how that space can evolve, so that you have more options, and you also have uh, from scratch design electric vehicles. And there are very interesting developments in these directions in terms of skateboard architectures, where the entire thing comes on a flat board, and then like changing the top hat, you can have different types of vehicles built on top of that, which will give a lot of variety options for the customer going forward. So those are the interesting developments in the electric vehicle part. And then all these vehicles will also have a lot of smart features coming in, and also the autonomous features in a step-by-step way. You are all familiar with the different levels of autonomy. So the autonomous features will evolve in the same direction. To start with simple parking assist, drive assist features may come in, and slowly they may move to a completely autonomous vehicle. That's the way in which that can evolve. But some of it is also about the ecosystem getting ready, which is in terms of the charging stations. We should be able to build the infrastructure of charging stations, especially fast charging, which is very critical for this to pick up momentum. So that has to happen. And then we also talked about manufacturing. Manufacturing of these vehicles will be very, very different from the current manufacturing. So we are looking at how the manufacturing technologies, how they will evolve, and how they will become optimized for building vehicles like this. And we talked about fewer components, and it's going to be much easier to integrate these things and build an electric vehicle going forward. And we are also been seeing industry 4.0, the digital manufacturing, a lot of good developments happening on the manufacturing space. And then we are also looking at building certain new manufacturing capabilities in the country to support all this. That becomes very important. Then sometime earlier, we talked briefly about some of the critical materials which have to be addressed early on. Otherwise, they could become bottlenecks for scaling up. So we need to do sufficient research to develop alternative technologies, and also what we call as recycling and reuse of these materials, so that we'll be able to comfortably manage the availability of these critical materials when we get into the scaling up. So there are a lot of opportunities for technology development and innovation at different levels, and it's going to be very, very exciting space. So for young engineers who are aspiring to get into the mobility space today, this is the best time, because there are so many interesting problems to solve, and so one can easily make an impact at the early stage of their career if they are getting into the mobility industry at this time. And so this is the best time for somebody to plan their career in the mobility space. So that way, this is really good.
Absolutely. Again, talking about technology, we recently, a suggestion from one of the participants. We had recently had the battery day from Tesla regarding tabless batteries. There's some metal air battery research that's going on in India. Um, what do you see as like out of all these developments going on? Is there anything that you find very interesting or exciting from an Indian context that would really be something that we should pursue further from what is happening already? Whether it may be, like how there is this tabless battery coming from an existing cell versus a completely different chemistry or technology.
Sure.
Anything that you feel would really be great for our context?
Sure. I'm not a battery expert, but I have sufficient expertise in materials so that I understand some of these material research challenges in the space. So based on that, I would say definitely there will be many alternative battery formulations that would come up in the days ahead. If you look at lithium air, lithium glass, variety of such things that's happening. That's a very, very active space for innovation. And a lot of technology breakthroughs are happening in the space. And what is the driver if you see? The cost of storing the energy itself. If you look at, we are looking at $100 per kilowatt hour kind of a target towards which all this is evolving towards. So this would involve materials, design, manufacturing. So this would involve innovations at all these three levels. It's not just materials, because any material, new material introduction would also be followed by optimizing the design and also optimizing the manufacturing methods for this. So if you look at the developments in these two spaces, manufacturing, especially additive manufacturing and 3D printing based things are coming up in a big way, becoming more and more affordable and also flexible. And the design, again, a lot of this design is going to come in such a way that the design of electric car is going to be very, very different from the design of the current generation IC engine vehicles. And we haven't seen all those big changes, shifts in the design so far. But in the days ahead, you would see all that. So they will be able to um, see many more innovative designs coming up in this space, because the designer has a lot more freedom and flexibility when they are working in this electric vehicle space. So they'll be able to exercise their creativity going forward. The car may not look the way it looks today. All those things, interesting developments also will happen in the space. So it's when we look at battery formulation, what whether new materials would come in? Yes, definitely. And what would drive? For example, when cobalt price started escalating, companies have worked to systematically reduce the amount of cobalt in the lithium-ion battery. The extent that today we use only about 1/6 of the cobalt that we are using a couple of years back. So that is one driver, the cost of the material itself. The second driver could be the fundamental scarcity of the material itself, which should force us to look at alternative materials. For example, when I was working with the GE earlier, we had a program on sodium ion battery. And so definitely there will be a lot of research happening on substitutes for lithium itself. But honestly, I don't know how long it will take to find a good enough substitute for lithium. So from that perspective, lithium will be around definitely for some more time. But in terms of overall formulations, the drive for newer formulations would be the cost of the material itself. Okay. So just like the way we saw less cobalt in today's formulation, there could be other changes that happens. And the third is to look at lithium glass, lithium air, these kind of fundamentally different designs coming in. And one driver would be the ability to design these batteries in such a way that the lithium and cobalt, all the critical materials can easily be extracted at the end of life and reused effectively. So that will be yet another driver for how the battery design and the overall manufacturing of these batteries, how they would evolve going forward. Since we are new, we are in India, since we are going to get into lithium ion cell manufacturing maybe for the first time, and then we are going to build this industry in the years ahead, it will be good for us to look at what is the latest in this technology space and directly leapfrog to the best of best technologies, the latest in this, when we make our investments. Because it will, we need not go through the same cycles that the rest of the advanced countries have gone through in lithium battery technology. We can directly skip a lot of these intermediate technologies and leapfrog to the latest. I think that would be a smart way to look at how we can build self-sufficiency in lithium-ion batteries for the country. I think that's how we should look at this space.
Okay. Yes, absolutely. And I think it's a great perspective on things. Not to keep following what's happening, but try to get to firstly what works for the for your for that particular country's conditions, as well as what's feasible, right?
Though
So
we do not know
Ramani,
the specific materials that may be in the future battery, but a target like this bringing it up $100 per kilowatt hour. These are the drivers for what materials will get adapted and what will get dropped. So at least we have those directions and the key drivers in place that will help us to prioritize in our research certain material systems over certain other systems. That much of direction and guidance is there.
Makes sense. Yes, having performance and cost targets tends to drive what you do. Correct. Correct. Absolutely. All right, doctor. So to round off the session, I have just one more question for you. Um, Alternate forms of propulsion, right? Big. We know there are challenges with with the current EV space. There are challenges with charging infrastructure, as we mentioned, battery tech, range anxiety. A lot of these tend to be not actual issues, but still considered as challenges. But there's also this a lot of talk about why just limit it to and my whole point here. We know that the future is electric, but from an energy storage system standpoint, batteries may not just be the only answer. And there are countries at least recently that are looking very seriously into adopting fuel cell, for example, fuel cell technology. What are your thoughts on that? From the industry or the mobility industry is a wide one. What may work for a two-wheeler application may not work for a highway truck or a long distance heavy duty truck. So what are your thoughts on this whole space of being talk about alternate forms of energy storage?
Sure. I'll give you three perspectives. One, as a Mahindra employee, the second as a technologist, and the third individually as a Shankar, what I believe in. Okay. So from a Mahindra perspective, we have been actually working on various alternative fuel systems. We started with the diesel in a big way, but we also explored gasoline, CNG. We even had demonstrated a hydrogen-powered Scorpio vehicle early on. So we have all these technologies in our portfolio. Depending on what the market wants, we'll be able to introduce any of these technologies into the products. So what we do typically is do all the basic research, technology development, and have it ready, and then just observe the needs of the market, what the customers ask for, and based on that, introduce these technologies into our products. So that we are not taken by surprise, we have everything ready, and then follow the market needs. That's how we typically do from a Mahindra perspective. From a technologist perspective, the way I would see it is a lot of it would be driven by what the customers ask for. So for example, today we drive into a petrol bunk and then fill our car's petrol tank and drive out in 5-10 minutes. So the user of an electric car also would expect and sometimes may even demand the same level of convenience, where if his battery runs out, he may want to get done within 5-10 minutes and then continue to drive. So this is not going to be easy in the case of a electric car. Getting your battery again charged in 10 minutes and then resuming your journey is not going to be easy from a technology perspective. So some people have looked at battery swapping technology. Some people are also looking at charging the battery on the go. Like there are pilot projects happening at Tel Aviv in Israel, also Seoul in Korea, where you have metal strips laid out on the road, and through inductive charging, when the car is driving, when you're driving this car on the road, it gets continuously charged even when you're driving. So that way, the more you drive, the more the charge you'll accumulate. But these are all at an early stage in terms of just pilot projects happening. So it may take some time for this to evolve. But what would basically drive the technologies in this space is basically the convenience of that the customers feel in terms of charging. Also, making sure that the range anxiety is addressed. They should never have the fear that somewhere they will get stuck because their batteries run out of power. So they should feel comfortable. See, although we typically may drive not more than 100 kilometers in a day, we ask for a range of 400 kilometers and 500 kilometers when we go for electric car. Just because this range anxiety is so big in our mind that we keep thinking only about that and forget everything else. maybe one day I may drive that 400, 500 kilometers, but every other day I'd be doing 50 kilometers and 60 kilometers. But still, I would ask for that requirement, which will take care of the worst case scenario. That's how typically most customers look at when it comes to the range. So that what the customers feel comfortable about. If I say that you're going to typically use only 50 kilometers in a day, why do you want 400, 500 kilometers? That conversation may not really work out at this stage. So it takes some time for the customers to understand their usage patterns and then go for the right specifications in terms of performance of the electric vehicle itself. So these things would evolve with time. So that's the customer feeling comfortable about something is what will drive the way the technology will evolve in the space. Finally, if you look at my personal opinion as Shankar, I feel that the battery powered, a fully battery powered electric vehicle is the direction that I would put my bets on, because I feel that from a convenience and performance perspective, and also from a cost perspective, that has a lot of promise and potential. Having said that, I also been observing this fuel cell space, how it has been evolving. Also, a lot of these companies who have been leaders in the space have now put all their patents in the public domain and encouraging people to go ahead and use their technology. So we have seen thousands of patents now being opened up for others to use and build their technology on top of that. But still, that is not happening. So in spite of a lot of research that has happened in this space, a lot of technology development, there seem to be certain inherent constraints which is preventing people from adapting this fuel cell based approaches. Since I'm not an expert in that space, I'm unable to comment more about it. But this is an observation as an outsider in the space. This is what I have observed. In spite of all the technology, in spite of opening the patents, there seems to be a lot of reluctance in picking up this particular technology at this time. So, as an individual, Shankar, I put my bets more on a fully battery powered electric vehicle as a technology going forward rather than anything else. That's how I personally see the space evolving.
Okay, thanks, Dr. Shankar. I have one more question.
Sure.
I wanted to understand what specific steps is Mahindra taking to reduce what the government is saying the royalty payments that the OEMs are paying overseas. So, with regards to Atmanirbharta and the royalty payments, what is the view of the company?
Sure. Honestly, I don't know sufficiently to answer this particular question. I can do two things. One is to talk to the experts and get back to you with the correct answer for this. And the second is also connect you with a few people at Mahindra Electric who can give you more detailed response for this particular question. So right now, I don't have sufficient information to answer you.
Okay, thank you. One last question.
Yeah.
How the startups are playing a role, and where do you see them fitting in compared to the incumbents and the traditional companies?
Sure, sure. Um, Startups will play a very important role in this space. So when you talk about electric vehicles, it's not just the electric cars. We're also talking about electric two-wheelers, three-wheelers. We're also looking at, there is this startup called E-Plane, which is based out of IIT Madras, which also looks at an electric airplane, which could be a four-seater or a six-seater, a small compact electric plane. So electric is that way, very interesting space. One need not limit themselves to only electric car. There are so many other interesting products one can pursue. And since the components are very minimal, and also the integration of all these components and building a vehicle is does not need a very elaborate infrastructure, one can easily do it even if you're a startup. So what will play a big role is the kind of innovative ideas and architectures that you are going to bring into work. That will play a very important role. in what could differentiate one startup with respect to other. The second is your ability to partner, because no one startup will be able to do this end to end. Your ability to partner with other startups and co-create the ecosystem, that will also become very important. The third is, of course, funding your work so that you'll be able to pursue multiple programs at a time and mitigate the risk of one program not really working out. So when I talk about funding and bringing in investors, it's not just the money, you're also getting a lot of mentoring and guidance from these experts. So this is a very interesting space because everything is new. So it needs a very fresh approach. So you need to involve the experts in a very careful manner, only on a need basis. Because there are very few experts because this technology is so new. So you're better off in thinking fresh and not being biased by what the experts say. So the first part, the early part of the ideation, I would encourage the startups to do something on their own. And then at the later part of optimizing and validation is where you should involve experts so that you are able to prioritize the right ideas and take them forward. But if you involve experts at an early stage, there is a finite risk that some of your innovative ideas may get killed because these experts are experts in something else, need not necessarily be in the space that you are trying to create. So that's one word of caution I would tell the startups who want to really make an impact in this space. But the startups will have a very, very important role to play, not only in terms of just the electric vehicle itself, but building the entire ecosystem for e-mobility. This is going to be important. And it's not just the vehicle technologies, it will also be technologies like artificial intelligence, machine learning, data science, whole bunch of technologies that are going to converge together and enhance the performance of these vehicles, which are electric, autonomous, and connected and shared. So there is so much of opportunity, there is so much that one can do in this space that startups will have a very, very productive time engaging themselves in this space.
Okay. So thanks a lot, Dr. Shankar, for all your insights. One of the things that we are trying to understand is what's the future of engineering colleges, especially the ones which are shutting down left and right, and with the current scenario kind of putting down a final nail in the coffin, so as to say. How do you see consolidation being a future element for the colleges?
Consolidation can very well happen. And one of the bigger things would be the digital transformation of higher education itself. For example, if you look at Georgia Tech, they launched an online master's program. They were the earliest to do that, and it's one of the best master's program, which is entirely online and very, very affordable, maybe 1/5 or 1/6 the cost of a regular master's program. So that is one digital transformation of higher education will, in a sense, democratize this. The best of best institutes will be able to offer master's program at a very affordable cost, and more importantly, to working professionals who cannot afford to take a break from their jobs and go and pursue a master's or a PhD. They'll be able to get the flexibility of doing such things in an online mode so that they'll be able to pursue their higher education after office hours and then at their own flexibility and pace. All those interesting developments will happen because of the power of digital technologies. We have been talking about digitizing and MOOCs and whatnot for a long time. But now in this 6 months, we have seen that these have really gone to the next higher level. And going forward, you will see certifications. For example, IT Madras launched this BSc data science and program. So these are interesting developments happening in this space because of the digital transformation of engineering education. One of the interesting aspects is the concept of virtual labs, because a lot of it can be done online. Then you ask experiments, how do you do it? How do you give exposure to students in terms of hands-on skills and stuff like that? So those are interesting areas for application of technologies like AR, VR, where we can create virtual labs and giving them that experimental training and exposure also in a virtual mode. So when we look at consolidation of colleges, that would definitely happen because the consumers of this education will be a lot more demanding. They want the best of best resources made available for them. And the cost of education would come down. And there will be more flexibility and freedom because of the online mode of education. And there will be also not just small bits and pieces like doing one course and get a certification, but there will be consolidation of courses so that you will be able to get a BSc or a master's degree by doing a set of courses in a systematic manner. So all these developments are already happening, and I expect to see more of this in the days ahead. That's how I see this space evolving.
Okay, thanks a lot, Dr. Shankar. So I think with this, we are at the end of the session as far as the Q&A. Thanks a lot for your time today, and it is really like the next generation is going to spring up a lot of new ideas and innovation. That's what the roadmap seems to be from the overall ecosystem between the startups and the bigger corporations. And I believe the bridge that we always talked about between the academia and the industry, it is much closer to becoming a reality than it was ever before.
True.
So thanks a lot again for your time. Thanks everyone.
Interesting session. I should thank you and Harsh for organizing this. And if there are more questions which we could not take today because of the time constraint, feel free to consolidate all that and email it to me so that I'll be able to respond to all those questions. And then also your questions that I could not answer, I will follow it up with our experts, Mahindra Electric.
Yeah.
And you can respond for that. Yeah. So these are some of the follow-up from my side that I will.
Right. Yeah, definitely. Thanks a lot, Dr. Shankar. Everyone else on the call, if you would like to stick around for a quick walkthrough of the Gyaniki platform, you are more than welcome. We can give a quick run through, and otherwise, I think you can continue with your Saturday activities and get going on that front. Yeah. Thanks, Dr. Shankar.
Thanks.